Okay, so this is going to be part B of solving quadratic equations by factoring. And a little hint here is to look for perfect square trinomials. Now, in order to solve by factoring, in almost any method of solving quadratics, you have to force the thing to equal 0. So I have to rewrite this by subtracting 45 from both sides. So I'm going to bring down my 25y squared minus 60y. And then I'm going to subtract my 45 from both sides here, and that will end up giving me a positive 36, and then now equal to 0. Well, it turns out that this is a perfect square, and this is a perfect square, so the possibility of this being a perfect square trinomial is pretty high. So what I need to do now is try to factor this using the perfect square techniques. Now I have a plus b squared, or I have a minus b squared as an option. And since there's a minus sign right there, it's probably going to be the second option, which produces the pattern of a squared minus 2ab plus b squared. So I'm going to go ahead and write down my parentheses with a square and a minus in between. And so the first thing I'm going to do is take the square root of the first term, and that will give me a 5y. And the square root of the last term, and that will give me a 6. And remember, the reason this is a negative is because this sign always comes down. Now, I don't want to just assume that this thing is a perfect square trinomial, so I want to test to see that it really is. Now, remember, the middle term comes from the a times the b, which will give me 30y, and then times the 2. It's actually negative 30y, and then times the 2, and that gives me a negative 60y, which is the same value I have up here. So that's how we know that we have a perfect square trinomial. Okay, so all we got to do now is solve. And if you remember in a previous video, perfect square trinomials produce a double root. Now this is set up so that we have one term raised to the second power by itself. So you're just going to use the square root property to solve this. So you're going to take the square root of both sides. And we could take the square root of 0 and just call it 0. There's no such thing as plus or minus 0. And then the left-hand side will end up being 5y minus 6 is equal to 0, because the square root will undo the power of 2. Now you continue solving, so 5y will equal 6, and then we divide both sides by 5, and y equals 6/5. And because there's only one answer here, and it came from a perfect square trinomial, we call this a double root. So this graph would actually have its vertex right on the x-axis. Example 7, the area of an isosceles triangle is 108 square feet. Find the perimeter. They're asking us to find the perimeter of the triangle. If the length of each leg is 15 feet, and the length of the base is 8x minus 14 feet, and the height is 3x feet. Now the best thing to do here is to draw a picture. And because they said it's an isosceles, that means two of its side lengths are the same. And they said they were both 15, so those are the legs right there, 15. And then the base value is 8x minus 14. They also told us that the height goes from the top straight down to the base, forming a 90-degree angle. So that height right there is 3x. And of course, they told me that the area is equal to 108. Well, if you remember how to calculate the area of a triangle, so area is equal to 1/2 the base times the height. All I got to do is substitute some values in. So the area A, that should be a capital A, the area A is 108. So this is going to be 108 is equal to 1/2 times the base value is down here at 8x minus 14. And the height value is right here at 3x. So 3x goes there. Now remember, to solve quadratics, we want to force the thing to equal 0. So I want to simplify the right hand side and then get rid of the 108 on the left hand side. So I'm going to distribute the 1/2 first. So this will give me 108 equals 4x minus 7. Now that's still in parentheses because I have to multiply it by the 3x that's still left over. So now I want to distribute my 3x to both of these. So that would give me 108 is equal to 12x squared minus 21x. And now I want to subtract 108 from both sides. 12x squared minus 21x minus 108. All I got to do now is solve for x. Now when you go to solve for quadratics, you want to pre-simplify everything out or just divide out the greatest common factor. So looking at all these numbers, the GCF here appears to be a 3. So I divide everything by 3 just to get rid of that 3 factor. I don't need it in there. And that leaves me with 4x squared minus 7x minus 36. And now you want to factor this and leave it set equal to 0 and solve for each factor individually. Okay, so I'm going to bring that to the top, 4x squared minus 7x minus 36. Now I'm going to solve this using the factor by grouping AC method. So my A times C is going to end up giving me negative 144. This is my A, this is my C, and that's my B. So I'm going to bring down my 4x and my negative 36. And remember, what I'm about to do here is break this negative 7 back into the O and the I of FOIL. So this is the F, and this is the L, and this is the O plus I. And I want to break it into an O and I separately. So I got to figure out the factors of 144 that have a difference of negative 7. And I think those numbers are negative 16 and positive 9. So I'll write negative 16x plus 9x. And now I want to group. Factor by grouping is what I'm doing. So the GCF of the first group appears to be a 4x, and that leaves me with an x minus 4. And the GCF of the second group is a 9, so that would give me an x minus 4. And I still have a common factor of x minus 4, and the factor that's left over when I bring the x minus 4 out is 4x plus 9. Now remember, this thing is still equal to 0. So now I'm going to set both factors equal to 0 and solve them both. So x minus 4 has the equal 0, or 4x plus 9 has the equal 0. And we have x equals 4 on the left-hand side. And the right-hand side, when I subtract 9 and divide by 2, I end up with x equaling negative 2.25. Now we're talking about a real-world problem here where x is part of this height on the left-hand side by this triangle. So this negative 2.25 doesn't make sense to the problem. So I'm going to ignore that solution and go with x equals 4. Now remember, the question was, what was the perimeter of the triangle? Well, we know we've got 15 plus the 15 over here. So these two 15s. The only thing I'm missing is the base number. And the base number was 8x minus 14. We now know that x is 4, so it's going to be 8 times 4 minus 14. So that will give us 32 minus 14, and that's going to equal 18. So plus 18 here. So add these together, and I get 30 plus 18. And 30 plus 18 is going to give me 48. And this was in feet, so the perimeter is 48 feet. Okay, so on example 8, they want us to write a quadratic function for the given graph. And of course, the function is supposed to look like this. The one thing you got to be careful of is finding out the value of a, because a lot of people, when they do this, they start with the roots and they work backwards, but they forget to calculate the value of a. Now we can see that the roots are right here. They are negative 2, and the other one is positive 6, which means our solutions were x equals negative 2 and x equals positive 6. Now if I want to turn these into binomials, I simply force these two equations to equal 0. So x plus 2 will equal 0, and that's one of our binomials that was created in the original problem. And x minus 6 equals 0, and that's our other binomial. So if I were to multiply these two together, it looks like it would give me those two solutions, and it would. The only problem is the rest of the dots that are along this curve may not actually fit. In fact, if I point out here the y-intercept, which is negative 6, so that's 0, negative 6. When I go to do the FOIL on here, 2 times negative 6, I end up with a negative 12 when I'm supposed to have a negative 6. That means I have an a value out here that's missing. And some of you could probably look at it and go, well, I know what the a value is. It's half. Because negative 6 is half, and that's correct. But sometimes you don't have the y-intercept available. So I'm going to show you how to do this by using that point to actually calculate what the a value should be. So I'm going to force this to equal f of x. And I am going to use the point right here, which is 0, 6 for the y-intercept of x and y. And I'm going to substitute 0 in place of x. So I have 0 plus 2 and 0 minus 6. And in place of f of x, that's my output values, which is the y, which is negative 6. And now I just solve for a. So I end up with a times 2, which is 2a, times negative 6. So I end up with negative 12a equals negative 6. And of course divide by negative 12 on both sides, and a equals 1/2. So you can say that the equation is, there's two ways you can do this. F of x equals 1/2 times x plus 2 times x minus 6. Or if you want to put it into this format that's up here, you can FOIL this out and you'll end up with x squared minus 4x minus 12, and then you've got the 1/2 on the outside. So when you distribute that, you'll end up with 1/2 x squared minus 2x minus 6 equals f of x. And now the y-intercept out here matches what the y-intercept actually is on the graph. So you could show it this way, but more often than not we show it this way by simply foiling out our binomial, and then whatever a value we have out in front we just distribute it on through. Alright, so on example 9 you can see that we have 3 points here and no graph. However, we do notice that this point and this point are actual roots or zeros of the function, which means x has to equal 1, x has to equal negative 7. Those are the two possible solutions. This point right here is going to allow us to determine the value of a. Now I am going to write my final solution in this format over here. But in order to do that, I got to start with two binomials, and that's actually pretty easy to do because you just take the solution here, force it to equal 0, so x minus 1 equals 0, and there's your first binomial. And then force this one equals 0, so x plus 7 equals 0, and there's your second binomial. So now we know that f of x equals a times x minus 1 times x plus 7. I just need to solve for a and then distribute everything back out. So the only way I can solve for a is substituting a value in for the x here and the f of x, and I'm going to get that from this other point off to the side, which is the negative 3 and the negative 32. Just remember the negative 3 is the x value and the negative 32 is the f of x value or the y value. So f of x is going to be negative 32. That's going to equal a times, and in place of x I'm putting negative 3 minus 1 times negative 3 plus 7 equals, and then negative 3 minus 1 is negative 4. And then the negative 3 plus 7 is positive 4. And that's going to give me a negative 16 times a is equal to negative 32. Divide both sides by a negative 16. We end up with a equaling 2. So I'm going to rewrite that. 2 times x minus 1 times x plus 7. I'm going to FOIL this out first. So 2 times x squared plus 6x minus 7. And then distribute my 2 all the way through, and I get 2x squared plus 12x minus 14, and then I just put my f of x back on there, and there is my function.